Hello, good morning. We'd like to present to you Homeseek. Our goal is to provide an affordable security system that prevents burglars from accessing homes, and break-ins in Mexico have augmented exponentially throughout the last decade due to our country's economy and government. The components of our prototypes are the following: Arduino, one piezo which works as alarm, one LED that simulates the lighting around the house, one button which is a remote control to open the garage door, one photo resistor, one peer sensor which detects movement, one gas sensor, one LCD display which will deliver the warning message, two servo motors, one that stabilizes the lock of the house and the other the garage doors, two breadboards, and all three sensors that we are using as well as the button work as input, while the servo motor, the LED, the buzzer, and the LCD are outputs.
The garage door motor is controlled by the gate remote control. Once you push the button, the servo motor will open, and when you press it again, the garage door will close. Here we have the gate remote control, and here we have the garage door motor. So if we start the simulation and we press the button, the garage door motor will open, and if we press it again, it will close. For this to happen, we used flags, which basically store the state of the button, and depending on what the state of the button is, it will either open or close the garage door. Then the second servo motor is called lock. What do we mean by that? This servo motor simulates all the locks of the doors and windows in the house. Initially, it will start at a 90-degree position, meaning that all doors are open. However, when the PIR sensor, which is located in the other breadboard, detects movement, the servo motor will go into a 0-degree position, meaning all locks will be closed. It also triggers an alarm so that the owners are aware of what is happening. Here we have the movement sensor, and here we have the servo motor that simulates all the locks. So if we turn it on, as you just heard, if it detects any movement, the alarm would sound and the locks will go into a 0-degree position.
So for this, we use simple functions. Prior to this, we set up a variable that will read the peer sensor. If it detected no movement, the locks will remain in a 90-degree position, meaning that they're open, as they've said before, and nothing would happen. This was the off danger function, this one. Both of these, the off danger and on danger, are simple functions. So, however, if the peer sensor detects movement, the locks will close, the alarm would be triggered, and the LCD display would write danger. This is the on danger function. But why did we include an LCD? The reason is quite simple. We also added a gas sensor, which is not connected to a digital pin, but to an analog pin. So the security system not only protects you from criminals, but also from your own kids or possible accidents. Because what's best and what we look for is the safety for clients. So the gas sensor reads the amount of gas that is circulating. When the amount of gas is remarkably high, this will also trigger the alarm, and the LCD display will write a warning message also that will say gas leak. So that's why there are two possible reasons as for which the alarm can sound. So in order that the owners or the clients or customers aren't confused as the reason why the alarm is making noise, we added the LCD display. So it can indicate if the pure sensor detected movement or there's a gas leak. Okay, let me show you. So once again, as we've seen before, if the movement sensor detects movement, notice how the lock begins in a 90-degree position. So if the movement sensor detects movement, the lock will close, all the doors will be closed, and windows as well. The alarm will sound, and the LCD display will write danger. Now with the gas sensor. This means represents that there is like a remarkably amount of gas gas around the room. So the gas sensor will read that, the alarm will sound, and the LCD display will write gas leak. Okay, now next. Finally, we included a photoresistor because while doing the circuit, we realized if it was all wired up, it would require a lot of electricity. So to make it even more attractive to the target market, it also saves energy. How? Basically, the photoresistor measures the amount of lighting it is exposed to. So it can basically tell if it's there or night because of the light that emits the sun. So when the photoresistor measures more than 280, all lights will be turned off. And when it's less than 200, no, I think it's 120. Yeah, sorry about that. When it's less than 120, the lights will turn on. The yellow LED symbolizes or represents the lighting around the house. So here on the code, you can see what I just said. So sensor value pH, which stands for photoresistor, will read the analog read A0, which if we go to the circuit, we can notice is the ambient light sensor, which is the photoresistor. So also in the serial monitor, we print both the gas and the light intensity. So it will read the value, it will print it on the serial monitor, and like this we can know we can know the value that it reads. So if it's higher or equal to 280, the lights will be low, which basically means that they will be turned off. And if the sensor value pH is lower than 120, the lights will be turned on, which is equal to high. So that's basically it. Now let me demonstrate. Let's move the gas. So as you can see, let me take this off. As the photoresistor value is lower than 120, the LED is turned on.